So, welcome to the Qt World Summit's meeting on where and when. This was originally billed as two separate talks on handling dates and times in Qt and making the most of Qlocale. They've sort of merged into one now. So I'm presenting them together as making the most of Qlocale, QDateType and their friends. So the agenda will be, I shall introduce myself. I shall introduce the easiest part of this, which is simple dates and times. There's also a bit on the calendars. Then it gets complicated with date times, where you combine those. And then the fun starts with formatting, the different ways the different cultures want to represent dates and times, and then moving on to the other things that different cultures and languages do differently when they're representing information of various kinds. If you have questions, you can type questions in the chat box during this presentation. This is a recording. I'll be online, hopefully at the same time as you, listening in as you do and ready to answer your questions. So do feel free to type in the chat and I'll see what answers I give. Maybe if there's some time at the end, we can use that also for some actual live discussion. I might want some questions to that if they seem more complex. So first of all, who am I? I'm Eddie. I've been making software less bad since 1982. I joined the Qt company as part of the Oslo core and network team 7 years ago. It's evolved into part of the foundations team, which looks after a broader range of things. My early work dragged me into looking at the way dates and times are handled. The first time there was a daylight savings transition, I saw a few interesting bugs and looked into them, and that was the rabbit hole I ran down. So I've ended up knowing a lot about how Qt does dates and times and localization and related matters. These are things that everybody just takes for granted how it's done, and as long as it's done right, nobody even notices that it's being done right. But the minute it's wrong, it's very, very wrong. So one has to be careful. Getting the right results is hard enough on its own. Doing so efficiently and without using any more machines or resources than we absolutely must is a further complication. Today's talk is not so much about the bugs I've fixed, I could tell legends of those, but about how to use the types that are now considerably less buggy than they were 7 years ago. So we can start with the easy parts, the date and the time types. To create yourself a date object, you just pass in the year, the month, and the day. You can optionally pass in a calendar. I'll come back to that. Likewise for a time, you pass in the hour and the minute. You can optionally pass in the seconds and milliseconds if you want. Internally, each of these reduces the several numbers down to just one, and they are just simply representing that information as an integer wrapped in a clever class to present it with different semantics. As a result, you can pass these types by value. The compiler ought to generate efficient code for doing that. You can pass in a date or a time just as such. There's no need to use a const reference as there is for complex types. Internally, the arithmetic that converts a year, a month, and a day to the simple number in the date type is pretty messy. It's not humongously clever, but there's just quite a lot of additions and multiplications and other fun things to do. As a result, you will get more efficient code if you're careful not to repeatedly ask for that information. Converting between the internal representation, which is just a simple day number from a fixed start day, converting between that and the calendar representation of it is not as cheap as simple arithmetic. In particular, internally, the calculation generates all three of those data, the year, the month, and the day together. So you can ask Qcalendar parts from date to map a Q date to all three of them, a little structure that carries the three. And this will be more computationally efficient than asking for the year, the month, and the day separately from the Q date object directly. Likewise, once you've got those values, it is better to hang on to them rather than recomputing them every time you need them. It's not prohibitively expensive, but it is an optimization worth exploiting if you're going to access more than one of them, or to access one repeatedly, to approach it this way. A date or a time can also be parsed from a string. They've got a from string method in each case to which you can pass a string that, as long as it recognizes the format, you may have to tell it the format. They will work out a date and a time from it. However, I will come back to this, but that is an expensive operation. So when possible, it is best to pass numbers to the constructors, the year, the month, the day, to the date constructor, the hour and minute to the time constructor. By default, we use the Gregorian calendar, which is the one everybody takes for granted usually. But we do have a Qcalendar type that lets us represent other calendars. It's relatively new, contributed in 2017 by Surush Rabier, and we've sort of tied it up and fitted it into the Qt framework as best we can. And we have done our best to design the internals so that more can be added. I should be very interested to see what happens once we actually do add one of the lunar-based calendars, which may require some changes to that, but we do want to support those if there are contributors contributing such calendars, and failing that, we might get around to it ourselves. For now, we have the Gregorian calendar, it's the default, the Julian calendar, which is its precursor that the Romans used before, and the Milankovitch calendar, which is a slight refinement on the Gregorian calendar from Eastern Europe. There's the Qlocale calendar, which is a Persian calendar, and the Islamic civil calendar are also both supported. Those are kindly contributed by Surush, and we are open to contributions for other calendars if other people know the details necessary to implement them correctly. The calendar object packages the detailed complexity of calendrical calculations. Their fundamental job is to turn a year, a month, and a day into a sequential day number. There are various queries they support, which is how many days are there in this month, how many days are there in that year, and how many months are there in a year. For the Gregorian and others, that's constant, but for the lunar calendars, that's a variable, and you will get extra months, some years. The calendar type is also recognized and supported by widgets. Some of them, the date time edit and Qcalendar widget do accept a calendar to use, to choose whose calendar to use. And there's a draft for how to do this in kernel, but it hasn't yet landed. Flop. All right, so the easy parts are covered. Now we get to the difficult bits. So a date time combines a date with a time. You have to decide whether that's the relevant time on that date here where I am, your local time, that time on that day according to UTC, according to some specific time zone, or using some specified offset from UTC. that's sort of like a lightweight time zone in effect, but a lot of date formats will print the date with an indication of its offset. And so often when reading a date from a standardized text format, you will get an offset from UTC. So that's what we use there. That does complicate the APIs for QDateTime in various places where you have to either pass a time spec to say which of those it is, but if you're passing the offset, the time spec that says offset, you're also going to have to pass an integer value for the offset. And if there's a time zone, well, you've got to pass a time zone. And so there's a different function for that. That complicates the present APIs. I'm in the process of creating simpler APIs that package those details in a thing called a QTime system. We might change the name of that before it lands. It's hopefully coming in 6.5. And it will make the datetime API simpler. And it will make life easier for people who write generic code, such as a widget to manage a calendar, for example. If they are given a date time from some source that's a client of their code, they can just use its time system as the time system they'll use for the calendar. And this will save them having to call different code paths depending on which of those types they're looking at. After you've constructed a date time, it's prudent to check whether it's valid. I'll come back to the details of why it might not be valid, but it is worth checking and considering what to do about it if it isn't. The type itself is actually the size of a pointer and could be passed around by value. We normally pass it by constant reference, in large part because its actual semantics internally are a bit more complicated than just a pointer. So we normally pass it as a constant reference, and I recommend doing the same just for consistency. You can construct a date time from a string by parsing it and making sense of the different fields in a carefully formatted date time, but parsing is expensive, as I have mentioned previously, for dates and times separately. So the reason why you might need to check that your freshly constructed date time is valid is that there are some times on some days in some time zones where there wasn't such a time on that day. This is a result of daylight savings time, but other changes to a time zone can cause this to happen. If a time zone winds its clocks forwards over an hour, well, the times in that hour don't exist for that time zone. That's true for local time, of course, because it's tied to whatever your local time zone is. And the complications on this are all driven by choices made by politicians who are thinking more about how easy it is for people to get to the park after work than about how hard it is to make software cope with the implied complications of what they've chosen. A zone that, even if it doesn't do daylight savings time, can change what its standard offset is pretty much everywhere at some point when it adopted the practice of having a time zone, changed everybody's clocks locally to conform to that time zone, and they may have repeated a bit of time or skipped over a bit of time. Sometimes a jurisdiction will decide that the time zone they settled on previously, the time offset they settled on previously, doesn't work very well, and they want to shift to a slightly different one for one reason or another, and they will make a change to their offset. In two memorable cases, they actually changed by 24 hours in order to shift from one side of the international dateline to the other, which of course meant the international dateline moved since their islands weren't about to move. And aside from those sporadic changes, you also have this practice called daylight savings time, where the clocks skip over an hour in spring and repeat an hour in autumn. Although those transitions account for 1 part in 3,000 of the time, more or less, their share of the code, and especially the bugs, is considerably bigger. They also complicate naive operations that you might think were obvious. There is a difference in principle between adding 1 day to a date time, which gets the matching time on the corresponding day, assuming the next day does have a corresponding time. It's not the same thing as adding 86,400 seconds. That's, for those who don't immediately recognize this number, 60 times 60 times 24. It's the number of seconds in a day. But if you add that many seconds and you've jumped, in the interval, there is a daylight savings transition in either direction, or a time zone transition in either direction, then you will get probably somewhere on the next day, but a different time, probably by an hour. That sort of thing normally doesn't matter for most people most of the time, because it happens in the small hours of the morning. But if you're planning your travel to get to an early morning flight, and you know that you're going to have to set off a certain amount of time in advance and get up a certain amount of time before that, in order to get to the airport early enough to check in with enough time to get to your terminus, you might just find yourself setting an alarm for 2:30 in the morning, and it's going to rather matter to you whether that happens the right amount of time before your flight, rather than, well, if there's 2 instances of 2:30 that morning, does it go off on the first one? Well, that's probably an hour earlier than you actually wanted. And if there wasn't a 2:30 that morning, what is your alarm going to do? It might skip the alarm entirely because the relevant time never came up, so the alarm never triggered. Or it might, when the clock skips from just before 2 o'clock to 3 o'clock, it might go, oh, I just stepped over in the time there's an alarm set for, I'll go off now, half an hour later than you actually needed it to, because you actually really needed it to land at 1:30, because that was the relevant amount of time before your flight. So those sorts of complications, they matter rarely, but when they matter, they mean you miss a flight, or some other complication. When the clocks go forwards, there's a gap in what representations are actually real, and when they fall back, there is duplication. So the big question is, what does software do when the user asks for a time that lands in a gap or that got duplicated? Up to Qt 6.4, we have resolved gaps by picking a time nearby. It is typically, well, if you take the time you asked for that didn't exist and add an hour to what you thought you were asking for, that does exist, so we've given you that. We might give you the one that's at an hour before in the same sense on some platforms, but I think it is consistently an hour later. The object that results from that will be invalid. This is to alert you to the fact that you didn't get what you asked for. And that's why I said earlier, when you create a date time, you should check whether it is valid. That object does have a sensible answer from 2 milliseconds since epoch. That will give you a value you can pass to from milliseconds since epoch, along with the same time specification as your time system as you were using for the originally constructed date time. And that will then give you a valid result that's a sensible approximation to what you wanted. It might not be what you, not be the right resolution. It's one of the 2 resolutions that we could easily have thought of. There are a couple of other ways we could resolve that, but the 2 most obvious are, if it's a 1 hour gap, well, an hour earlier or later than you asked for. There's no way at present up to 6.4 to say which side you would prefer to fall of such a change. But at least for gaps, you do at least get alerted to the fact that you hit one by the fact that the result is invalid. For a duplicated time, one of them is picked. I think it's the first. It will be a valid date time, so you get no hint that this has happened. And you get no way to find out that there's the other to ask for. I am working on providing control for that. It is a bit technically complex, and getting the right balance of too complicated a set of options for practical use versus actually addressing all of the cases that we can see a sensible case for wanting requires a bit of thought, and that is in review and being thought about. So hopefully it will be possible to get a better resolution in 6.5, but I can't promise that just yet. All right, so you've got yourself a date, a time, or a date time, and you want to show it to the user, or you want to communicate it to some other piece of software that wants it represented in a textual form. That means you're going to have to generate the text that formats the date time in a recognized way. Likewise, if you've got data coming from another piece of software or from the user, you're going to need to be able to make sense of that text as a date time to use it internally. And there are many different ways to format dates and times. There's probably one that you think is totally natural and normal, and why would anybody else use it differently? And the only thing I can tell you is that other people do it differently, and don't assume everybody does the same way as you. I can't say more about locales in a bit, but Qlocale probably knows how your user prefers to see date times formatted. It also knows the right names for weekdays and months as part of that. And it can represent dates and times in a user-facing way. For dates and time representations coming from other software, you will typically find yourself looking at a format specified by some standard. That might be the International Standards Organization ISO 8601 standard date format, or it might be the formats from one of the RFCs that define the internet protocols. Those date formats are standardized, and they are known by Qdate, Qtime, Qdatetime variously. Those types use the Qlocale, which is kind of a geek form of United States English. It has some quirks that are down to the really originating in the early C libraries for programmers. But it's a standard set of formats that are widely used. And they are suitable for communicating with other software. So use the two string methods of Qdate, Qtime, Qdatetime, and the from string likewise for compatibility with other software and for public standards. When you want to communicate with the user, use Qlocale's two string methods variously, and it's got a corresponding to date, to time, to date time methods, which will read a string as an appropriate time. Now, I've mentioned a couple of times that converting strings to dates, times, and date times is expensive. This is intrinsically true because making sense of a string as a number is not automatically simple. Unfortunately, we are in a worse situation than that, as described by the Qdebug listed there. Once upon a time, we had a datetime edit widget that was designed to let the user modify an existing date and edit it until they had the date they wanted, and then say go. That, as a result, does a sort of incremental parsing of the date time. So it starts out knowing all of the fields, and you edit one field and you edit another field, and it adapts suitably. When somebody noticed we needed a parser for dates and times, the quickest way to get there was to extract the parser internal to that and rework it slightly to work for just reading from a string. The result is that the architecture is a little eccentric and not really ideal. If you were starting from scratch to write a parser for date time strings, you wouldn't do it the way it is. And I can see plenty of ways to improve it, but fundamentally a new parser needs to be written from scratch, which has gotten delayed because there is a lot of other stuff to do. So at present, parsing of dates and times is more expensive than it needs to be. And even once it's been being done better, it will still be more expensive than passing numbers to the constructor. So anytime you've actually got numbers to pass to the constructor, I recommend you do so. I have seen a remarkable amount of code in which people use a from string method to construct a date or time instead of passing numbers to the constructors. And that is inefficient because their source code already contains the numbers inside the string that they're parsing. And it's more efficient to just pass the numbers in to the constructors. All right, moving on. So dates and times, the first part of this talk. The remainder is about localization. This is a process that is in fact subject to itself. The very word localization is different in different cultures. There are enough that start with an L, end with an N, and have 10 letters in between, although those letters vary, that it is called L10N in the peculiar jargon of international standards. And it's represented in Qt by the Qlocale type. That looks after all of these things, like what is the right format for this cultural context, for dates, for times, for numbers, for amounts of money. You might think that those are just numbers, but it's more complicated than that. Accountants have their own ways. How do you organize data into a list? How do you represent a quote? All of those things vary from one culture to the next. And the details for how they vary have been collected together by the Unicode Consortium into a data repository called the Common Locale Data Repository, CLDR for short. It provides a reasonably authoritative source of data on how to deal with localization. That includes the correct number system to use, which is what digits appear in your numbers and what separators appear in your numbers to group the digits. A lot of European cultures group the digits into threes, but that's not exclusive. There's Indian cultures that group them into twos, except for the last group being a group of three. There's all sorts of little subtle rules in how you format a number that are different from one culture to the next. Other things that depend on your cultural context, the locale, one of those is the sorting of texts. What order do the words appear in a dictionary, or what order is the alphabetic order you should use for listing things to make it easy for a user to find the entry they want because they know their alphabetic ordering. You might think that's obvious because the alphabet has an order, but what if your language has accented letters? How are those handled? It varies from language to language and culture to culture. So in some cases, the version of a letter with an accent on sorts adjacent to or even alongside the version with an accent, without an accent. In other cases, you get, for example, in Norwegian, there is a letter which is an A with a ring on top, and that A ring character, pronounced or, is actually the last letter of the alphabet. So it doesn't sort alongside the letter A at all. So if you're sorting for Norwegians, you don't want to put things that start with an A ring with the A's, you put them at the far end of the alphabet. All of those things are called collectively collation. We have a type Qcalator which looks after those. Qlocale is intimately involved with it. The two have to talk to each other. So you can use that to sort strings in the right order to suit the culture of your user. The Qlocale will also tell you the appropriate way to name the language or territory that it's specific to in the relevant language. There's more data in the Qlocale data repository that we don't yet do anything with. We haven't really seen a call from it from users, but if there is data that you think varies from culture to culture and we don't do it right, do let us know. We can probably dig the data out of CLDR and work out how to include it in Qlocale and use it to solve those problems. So that's what Qlocale is. Now, how do you get hold of one? Well, you're going to construct one in the usual way for C++. And usually the right thing to do is just to use the default constructor. Pass no arguments, just Qlocale, open parenthesis, close parenthesis. That will usually be the right locale for communication with the user. It, by default, is the Qlocale system, which provides access to the underlying operating system's knowledge of what the user wants as their localization. That may indeed not match any particular country, language, or any of the usual ways of doing things, because the user may have their own custom way of doing things. It is possible for your software to override that. This can be relevant if the user doesn't want to configure their entire system just to use your app to do one thing that they want to do with a different locale. If they're writing a letter to a correspondent in another country, they might very well be using that country's localization for the letter. So they might start up your app and go to its settings and say, can we use a different locale today? If they do, well, you'll be able to construct a locale by parsing a specific language, script, and territory as appropriate. The script and territory may be optional. You can leave out either or both of them. If you do give both, the script must come before territory. But you can use that to construct a locale for any language, script, and territory known to Qt. There is a caveat on that, which is if it is not a supported locale, well, you'll end up getting some other locale than the one you asked for that's our best shot at something that approximates what you asked for. I'll come back to the details of that in a moment. And when you do that, you get a locale object that you can pass to Qlocale set default. That can then be used as the default by various things. It certainly will be used extensively internal to Qt. Things will be using the default constructed locale. And that will mean that when people start up widgets within your application, by default, they will get that locale. You can override that for particular widgets, give an individual widget a locale to use in many cases. Generally, you're going to want to consult the user if you're going to do that. Typically, in fact, that will even be user initiated. You're provided in your settings panel for the user to select a locale. Your code can then ask Qlocale for a list of supported locales. It can offer the user a suitable textual representation of each. Behind the scenes, it'll have tied to it a memory of what was the actual language, script, and country for it. Once the user selected one, you can take the one they asked for. Even when you have configured a default locale like that to override what the user is going to see for this run of this app, there will be some situations where it may be appropriate to use Qlocale's system directly. Even though it's not the default locale anymore, the system locale is probably the right thing to use, for example, if you're writing to a system log file in some way. And it's often the right thing to use when reporting something to the user in a pop-up dialog if you're alerting them to some concern that they need to attend to that's not really relevant to what the app itself is doing. It's incidental to the app. You can represent locales by rather compact strings. They're probably not very intelligent. I'm going to be using some in the next slide that combine a short form of the language name, a script name, and a territory name. Again, it can leave out the script or the territory. It might provide only one of them or both of them, but the language is generally required. And it joins those fragments with dashes or underscores. And you can construct a Qlocale from that. It is not free, it is cheaper to parse the enumerations that are the language scripts in the territory, but it's not hugely expensive. It's just a matter of searching the tables of those to find which fragments you've given it. Now, I mentioned that you won't necessarily get what you asked for. If you ask for an arbitrary combination of language script and territory, there won't be data for it. For the most part, most of the languages supported by CLDR are used in a minority of the territories and with only one or two scripts for each language. So if you choose an arbitrary combination, you won't get what you asked for. What you will get is something for which we do have locale data. It will have the language you asked for as long as there is any data for that language anywhere. I think there may still be some languages supported, nominally present in Qlocale's list, for which the language will be mapped to another language. That would hopefully be as close a match as we can find a close related language if CLDR has given us data for that. But in extreme cases, you will be dropped back to the C locale, which I previously mentioned. It's not a good choice for the users who've asked for something unusual, but it's our sort of fallback locale. If you do get the C locale when you could have sworn you were expecting something else, it is probably reasonable to try using the system locale instead. But when the CLDR has no data, it has some rules. They're called likely subtag rules, which say, given the tags you've got, which of them are you going to care about more? So we'll take the language and we'll go, okay, what's the likely territory for that? What's the likely script for that? And we'll end up using that using the likely subtag rules to select the closest match we can to what you've asked for. For example, if you've asked for German as it is spoken in the United Kingdom, Great Britain, and Northern Ireland, you won't find any data for it in CLDR, and so it will fall back on a suitable German, namely German as is spoken in Germany. That's usually just what you needed. It's the best you can hope for, and you get on with using it. But you should watch out for little pitfalls, the most obvious example of which is if you ask for the native territory name, well, you're going to get the native territory name of the locale that got selected, not the one you asked for, because the locale data for German as it is spoken in Germany doesn't know the name for Great Britain, the United Kingdom, Great Britain, and Northern Ireland in German. It only knows the name for Germany in German. So if you're going to use native territory name, be sure to check the territory you've got is the one you asked for. And if it isn't, you're going to have to think about what else to do instead. In many cases, the right thing to do will be just accept that you can't report the territory, or give the territory in the language you already have it in, which you can get the territory name in English. Qlocale will tell you that. But that's not ideal, but it is better than giving a different country's name in the chosen language instead of the right country's name in the wrong language. So there is one exception to that, which is the Qlocale system, the system locale object, which represents the user's configured options in the operating system, will use what the system tells us. And that means if the system says that you've configured it to use German as it's spoken in the United Kingdom of Great Britain and Northern Ireland, then it will indeed do things to the best of its ability that way. This does have the complication that if the system doesn't tell us, doesn't give us a useful answer to a query about something Qlocale can report, we will fall back on what CLDR gives, which will then go via the above mentioned likely subtag rules, and so you will then get potentially not what you wanted. So actually in that case, you might have a Qlocale system that reports its territory as being Great Britain, but when you ask it for its native territory name, you might end up getting Deutschland if the operating system hasn't supplied us with a native territory name to say what Great Britain is called in German by the people who speak German in Great Britain. When we are reporting suitable language used for translation, the operating system may leave out the localization the user requested, or more to the point, the localization that's actually represented by the things we call to get the language and territory for the locale. They may leave that out of what they think is sensible to use for translation. For example, if the operating system itself doesn't come with translations for that combination. That's potentially a problem if Qt and your app do have translations for that combination. So we do include that combination in the UI languages that we return, even if the operating system misses it out. If the operating system includes it or a match for it by the likely subtag rules, then we'll leave the list they give us untouched. But if it completely misses it, we will put the one that's being represented by the system locale at the front of that list to help you get the right translations for Qt and your app. And that is all I have for you today. I hope there have been some interesting questions that I'm hopefully still answering on the chat. And if there remains time in the 3/4 hour slot, maybe I will come on the microphone and answer some of those by talking to you. That aside, it is time to stop recording.